Apollo sent 6 crews down to the moon, and every successful landing changed what the next crew could attempt. Choosing the greatest surface mission cannot mean choosing the most famous photograph. It means asking which expedition used its brief, dangerous stay to accomplish the most complete work. The field here is narrow. The 6 Apollo missions that landed people, worked on the lunar surface, and returned them safely. Orbital triumphs, and the rescue of Apollo 13, belong to other contests. This one is about exploration after the landing legs touched dust. A lunar expedition had to carry its shelter, oxygen, tools, cameras, experiments, and escape vehicle across nearly 400,000 kilometers of space. On the ground, bulky suits reduced touch and movement. A small navigation error could waste hours, and a torn suit could end everything. So the comparison needs more than one record. We will weigh whether each crew achieved its assigned mission, how far and intelligently it explored, the quality of its field science and samples, the difficulty of its operations, and the value its work retained after the crew came home. The missions also belong to different generations. The early landings were cautious proof that humans could arrive and leave. Later flights carried an electric rover, heavier scientific equipment, and enough supplies for several long moonwalks. Comparing them fairly means rewarding achievement while recognizing inherited capability. That creates the real mystery. The first landing has unmatched historical consequence. The later missions had better tools and more practice. The GOAT must be the flight that turned those advantages into the strongest all-around expedition, not merely the one that happened earliest or stayed longest. Apollo 11 established the field in July 1969. Neil Armstrong and Buzz Aldrin landed with little fuel to spare. For roughly 2.5 hours, in the compact experiment package, collected samples, and proved that people could operate on another world. Nothing else in the contest equals that first step. Yet the mission was deliberately conservative. The astronauts stayed near the lunar module, traveled on foot, and left after a short surface visit. Apollo 11 opened the door, but it did not have the time or equipment to explore far beyond it. Apollo 12 showed that a landing could be precise rather than merely survivable. Pete Conrad and Alan Bean touched down about 535 feet from the unmanned Surveyor 3 spacecraft, close enough to walk over, inspect hardware that had spent years on the moon, and bring pieces home. That pinpoint arrival mattered because science targets are rarely placed in convenient, open plains. Apollo 12 also deployed a more substantial automatic experiment station and completed 2 moonwalks through the ocean of storms. The mission made accuracy itself an exploration tool. Its limitation was scale. The crew still moved on foot, carried modest loads, and worked within a compact neighborhood. Apollo 12 was a wonderfully controlled expedition, and its retrieval of Surveyor parts was unique, but later missions would turn a landing site into a genuine regional field area. Apollo 14 returned the program to the moon after the Apollo 13 accident. Alan Shepard and Edgar Mitchell landed at Fra Mauro, the rough highland region intended for the aborted flight, and restored confidence by completing the mission that the previous crew had been denied. They pulled a 2-wheeled equipment cart called the Modular Equipment Transporter. It carried tools and samples, but dragging it over broken terrain was hard work. The crew searched for the rim of Cone Crater. Woe's ejecta could reveal deeply buried material, yet confusing landmarks stopped them just short. Apollo 14 still returned valuable rocks and deployed a full experiment station. Its strength was resilience. It recovered a shaken program and pushed into more difficult ground. Its weakness was that the most important traverse ended without the crew knowing how close they had come to its target. Apollo 16 attacked a scientific question the earlier landings could not answer. John Young and Charlie Duke explored the Descartes Highlands, terrain thought to have been shaped by ancient volcanism. Samples instead showed that impacts had dominated the landscape, overturning the expected story of that region. The astronauts had a rover, 3 moonwalks, and more than 20 hours outside. They covered about 16.5 miles and returned roughly 209 pounds of material. A geological rake let them gather many small fragments efficiently, broadening the sample rather than relying only on conspicuous rocks. Apollo 16 also reached House Rock, a boulder large enough to earn a domestic name on an otherwise domestic-free world. The crew sampled highland breccias, rocks welded from impact fragments, and gave scientists a much stronger look at the moon's battered crust. But execution was not spotless. Young accidentally pulled loose a cable for the heat flow experiment, permanently ending that measurement, and technical problems shortened the mission by about a day. Apollo 16 produced major science, though part of its planned return was left on the surface. Then came Apollo 15, the first of the longer scientific missions NASA called J missions. David Scott and James Irwin landed beside Hadley Rill, a deep channel near the Apennine Mountains, while Alfred Worden operated a bay of mapping and sensing instruments from lunar orbit. Its defining machine was the first lunar roving vehicle, a battery-powered car designed for the moon. The rover expanded the crew's reach from walking distance to several miles, while television viewers watched it cross a landscape that finally looked less like a campsite and more like a field expedition. Apollo 15's geology was equally strong. The crew collected the Genesis rock, an ancient piece of lunar crust, studied the edge of Hadley Rill, and returned about 170 pounds of samples. From orbit, Worden's instruments mapped the surface and measured its chemical character. This is the strongest rival because it changed the operating model. Apollo 15 did not merely use a rover. It proved how a mobile science-led lunar expedition should work. Any later winner must show that it did more than inherit that template. It must demonstrate a meaningful improvement in range, evidence, and execution. Apollo 17 is the GOAT of crewed lunar surface exploration. The final Apollo landing combined the mature J mission hardware with the program's most explicitly geological crew, then used that combination to set the strongest overall standard for work on the moon. Gene Cernan commanded the mission, Ron Evans remained in lunar orbit, and Harrison Schmitt became the first professional geologist to walk on the moon. Earlier astronauts had trained seriously in geology. Schmitt brought a career field scientist's habits directly into the crew, especially the instinct to notice material that did not fit expectations. Their destination, Taurus Littrow, was a valley between mountains on the edge of the Sea of Serenity. NASA chose it because one landing area could expose both very old highland material and evidence of comparatively young lunar volcanism. It was a compact landscape with several chapters of lunar history pressed together. Apollo 17 remained on the surface for about 75 hours. Cernan and Schmitt completed 3 moonwalks, lasting just over 22 hours in total. The rover carried them about 19 miles, farther than any previous lunar crew, through a chain of stations selected for distinct geological questions. Range alone would not win. What mattered was how the crew used it. They described layers, boulders, craters, and soil, while mission control geologists listened on Earth. Schmitt could revise a sampling decision in real time, and Cernan could translate that scientific priority into efficient movement and equipment work. The mission returned about 243 pounds of lunar material, the largest Apollo sample haul. Quotes mattered because the rocks came from varied settings across the valley. Scientists received not one dramatic specimen, but a broad, documented collection, tied to observations made at each stop. At Shorty Crater, Schmitt noticed orange soil beneath the usual gray surface. The color came from tiny beads of volcanic glass, material created by ancient fire fountain eruptions. It was a genuine field discovery, an unexpected visual clue recognized on the spot, sepsed quickly, and later used to reconstruct lunar volcanism. The automatic experiment station added another layer of value. Instruments measured the lunar environment after the crew left, while charges and geophones, which are ground motion sensors, probed the shallow structure beneath the valley. The surface work was designed not only to collect objects, but to make the site itself an instrument. Ron Evans made the expedition more complete from orbit. Cameras and sensors mapped regions the landing crew could never reach, and he performed a spacewalk on the journey home to retrieve film from the service module. The mission's science therefore connected detailed field observations with a wider view of the moon. Apollo 15 deserves the hardest comparison. It introduced the rover, established the J mission method, and made a leap larger than the refinement that followed. But GOAT status in this exact field rewards the best completed expedition. Apollo 17 traveled farther, worked longer, returned more material, and placed a geologist inside the landing crew. The winner was not flawless. It benefited from every earlier landing, and some planned measurements did not work perfectly. Its status also carries an uncomfortable condition. NASA canceled the missions that might have surpassed it. Apollo 17 became the mature endpoint of a program that stopped just as lunar fieldwork was becoming truly capable. That is why the last mission wins without diminishing the first. Apollo 11 proved humans could reach the moon. Apollo 15 invented the modern expedition. Apollo 17 brought the system closest to its full purpose. Combining mobility, professional observation, sample return, experiments, and orbital mapping in one coherent scientific campaign. Its GOAT status matters because exploration is not measured only by arrival. It is measured by how much understanding can be carried home from a place that is trying to kill the explorers. Apollo 17 had 3 days on the moon, and used them like a field season humanity still has not matched.